Hello, in this video we're going to work through this practice problem. So this problem was from an old test, and this was from the full code response part where students were to write a full coded section. Now as you can see, I've actually given you a little bit of the setup. The reason for that is the stuff earlier, or the stuff that you see here, we've already learned how to program. So the first step with any of these problems is understanding what it's asking. So below is a coding segment which takes the inputs for 3 integers. The program should find the smallest possible sum of 2 of any of 3 integer values. The values of A, B, and C do not have to be unique. So essentially what this is saying is that we take 3 integer inputs, and then we have to figure out the sum of 2, which is the smallest. So let's take, for example, here the example of A is 4, B is 9, and C is 1. So I'm going to, if I was doing this on a test, I'd probably start by kind of writing these out. So we have 4, 9, and 1. And even though we can very quickly see that the smallest sum is 4 plus 1, which is 5, I might go through some little testing here. So 4 plus 9 is 13. Well, that's one value. And I could also do 4 plus 1. 4 plus 1 is 5. Well, now let's take the 9. Well, what about 9 plus 1? We haven't gotten that one. It's 10. So these are the only possibilities I have. So I could add the 4 and the 9 to get 13. So that's adding the 4 and the 9. I might add the 4 and the 1. I might add the 9 and the 1. So if we extend this to a bit more general situation, let's, instead of saying 4, 9, and 1, let's say A, B, and C. So what are my combinations here? Well, 4 plus 9 is like saying A plus B. So A plus B is one possible combination. 4 plus 1 is like saying A plus C, so there's another combination. 9 plus 1 is like saying B plus C. So there's only 3 combinations that we can have here. So I need to figure out which one of these 3 is the smallest, and then I'm going to assign that to smallest sum. So I've coded a couple possible solutions here, and I'm actually going to include this in your OneNote file if you want to take a look at it later. So we're just going to pop up our program here, and just a couple comments about this before we dive into it is you'll notice there's a whole bunch of code here. These are 3 possible approaches students might take. And you'll notice I've put each one inside of a while loop, while true. You can see it right here in this case, commented out right now. And the reason I did that is so I can test it, do a number of tests without restarting the program every time. So I'm going to start with what I would say is the most likely approach by a student. And that's this one here. So let's bring this one in. We'll take out these // and the /*. So there we go. And this is probably the most likely approach that a student could make. And so what a student does in this approach is again, notice this while true is just set up. There's the start of the while and there's the end of the while. That's just run so that this will run over and over. So here are my inputs. And what the student has done is set up 3 different if statements. So if we take a look at the logic, what they do is by checking by looking at the only combinations, that is A plus B, A plus C, or B plus C, we can check each combination. And since there's a small number of combinations, that's pretty straightforward. So I check, is A plus B less than or equal to A plus C? And is A plus B less than or equal to C plus B? So there's my first combination. If both of these are true, then we know the smallest sum has to be the A plus B. And I essentially do the same statement in each case. So if I run this now, what's going to happen is it's going to come in here and it's going to say input A, input B, and input C. So let's test a couple combinations. I might do 1, 2, 3. We see the smallest sum is 3. 1, 3, 2. 2, 1, 3. 3, 1, 2. 2, 3, 1 could be a combination. 3, 2, 1 could be a combination. Now, this is where students often kind of make a little mistake, because they'll forget that I make the point that the numbers might be the same. So it could be the case of 2, 2, 1. Smallest sum is 3. 2, 1, 2. Smallest sum is 3. 1, 2, 2. Smallest number is 3. And I could have a case where all 3 are the same. So 1, 1, 1, the smallest sum should be 2. So I can see now that this situation works for every case. And since this is an infinite loop, and while there, since it's an infinite loop, I have to actually manually terminate the program. Now, a nice little subtlety here is I probably want to make these else ifs, right? Because, of course, if this first one passes, then we know this has to be the smallest sum, therefore the other ones aren't necessary. Of course, if we run this, we'll see that 1, 2, 3, 1, 3, 2, 2, 1, 3, 3, 1, 2, 2, 3, 1, 3, 2, 1, 2, 2, 1, 2, 1, 2, 1, 2, 2, 1, 1, 1. Okay. Now I've written out all these test cases to test them. Of course, in the test, you're not going to be able to test all these test cases, but one of the strategies for problems like this is to think about all the possibilities that could occur, especially with problems where there's a smaller number of possibilities. That's a useful first step. Of course, more complex programming problems are situations where you can't imagine all the possibilities, so you have to think in a more general sense. Okay, so that's probably the most common approach. So let's put a comment here. This is probably what I say is the common approach, and that is find all the sums, all the possible sums, and compare them. Okay, pretty straightforward approach. This would be the next approach that I would see. And actually, before I can comment this out, so slash star, and then I come down to the bottom and I'll put a star slash. That's a way to comment out a large chunk of code. So this is probably the next approach that I see commonly made by students. So this approach, so this is probably a less common approach, which is a good, but this is a good one. What we do with this is we find the largest integer value, then we add the two smaller ones. So again, this is inside a while loop. While true is always going to be true, so this will loop forever, and that's just so I can demonstrate a couple examples for you. And while, so if we run this now, it's going to pop up. And actually, let's go in here and explain before we run it. So we take our inputs there, and so what we do is we say, is A greater than or equal to B, and is A greater than or equal to C? So if both of these conditions are true, then A has to be the largest integer, so the smallest sum is going to be the other two. And we do the same thing for B and C. So you can see the code is very repetitive. And in fact, this first approach and this second approach are very similar. The only difference is that whereas notice in the first approach we actually compared the sums, the second approach we only compare the values. And this can be argued to be a little more efficient, though it makes no real impact, well, no impact on our actual program here. So again, in this approach, what we did is we found the largest integer, and then we said, well, if we have the largest integer, the smallest sum must be the sum of the other two. So if I run this, of course, so we give this a run, 1, 2, 3, of course it works, 1, 3, 2, 2, 1, 3, 3, 1, 2, 2, 3, 1, 3, 2, 1, 2, 2, 1, 1, 2, 1, 1, 2, 2, and then 1, 1, 1. Notice I've done a slightly different example here, where the two outer ones are the smaller and the middle ones. So we want to account for the case of 1, 2, sorry, not 1, 2, 1, 2, 1, 2, right? So again, even though this is a test and you're not going to be able to do this, when you're programming, it's good to set up a situation where you can do a lot of test cases. The better you get, the less you have to actually go through these test cases. Okay, so let's comment this out again. So slash star, star slash, and let's take a look at the most efficient approach. And this is an approach some students did, and of course, even though this is a test on conditional statements, you'll notice there are no conditional statements here. So when I was learning to program, we didn't actually have this min method, or min function, as we've called it sometimes. And you can actually exploit the min function here. So again, this is inside a while loop in order so we can do a whole bunch of test cases. And what we do is we actually use this min method. So we know that if I have three integers, the possible sums are AB, AC, and BC. So what I can do is I can first, again, we'll work from the inside out, I'm going to find the smaller of AC, or A plus C, or B plus C, and that's going to be generated and put in there, and then once I know the smaller of those two, I can check the result against this AB, and find the minimum there, and then put it directly into smallest sum. And lo and behold, 1, 2, 3, 1, 3, 2, 2, 1, 3, 3, 1, 2, 2, 3, 1, 3, 2, 1, 2, 2, 1, 2, 1, 2, 1, 2, 2, 1, 1, 1. Of course it works. Now there's one or two little cases I haven't actually addressed in this, but they would work. And see if you can figure out the cases that I missed in here. So again, three approaches, all very valid. So this approach 3 is probably the most elegant, I would say. I'm going to say it's the best approach is to use the math class. Okay, and that's a nice little approach because what this approach does is it means it's very little code. So again, our three approaches are: we could use the math class, we could compare, we could find all the possible sums and then compare them to find the smallest, or we could find the largest integer and then add up the two smaller ones. I hope this helped.